So we're talking about the difference between the two formulas, right?
Mm-hmm. So, from what I can understand, you use the confidence interval in order to estimate a population's parameter, like how certain you are that your sample mean is right.
Yeah.
And then you use your margin of error to show the possibility of your answer being wrong. So like the confidence interval is what's right, and then the margin of error is how much you could be off.
Yeah, I think so.
Okay, cool. That makes sense.
Wait, is there a formula for margin of error?
Yeah.
So I only have the confidence interval and the sample size formula.
Okay, which was the sample size formula?
N equals z times standard deviation over margin of error squared.
Mm-hmm. I guess your margin of error is kind of built into your confidence interval.
Okay, got it. Oh, that's right, because margin of error is, oh, wait. Maybe not. Relook that.
So do we have any other questions besides where the formulas come into play and the numbers and stuff like that?
I actually just wanted to find out for number 8, where do we how do we put the numbers into the confident interval formula?
So the numbers that you're going to put in there is going to be 541 plus or minus 1.96 times 32 over the square root of 50.
Okay, sweet.
Does that make sense?
Yes.
Wait, so the margin of error, that's going to be the second part of that formula, right? If I remember correctly.
Yeah, it's the 1.96 times the standard deviation.
Okay.
Seriously, what is wrong? It's frustrating.
What are you trying to figure out?
Just my computer. I don't know why it is being dumb right now. Like I only see your pictures. I don't see you.
Oh, that's weird.
Anyways, do we have any other questions from the homework assignment?
Not me. I'm good.
Okay. Do we want to start the test?
Sounds like a good thing to do to me. I don't know. If I didn't have to take the test, I would say no.
Alright.
Hold on one second. Oh my, come on. My life. Okay. Come on, you can do it, computer.
My computer's like heating up right now.
Okay, that was helpful. You guys, if I lose you, it's not my fault.
Just make sure that you copy and pasted this link already then.
Google. It's not letting me log in. Okay. Come on. I don't understand.
What's happening when you're trying to log in?
It keeps refreshing.
So open up a new window.
Yeah. I'm in iLearn now.
You are.
Yeah. Now I'm trying to get in the group meeting.
What
Quick.
browser are you using?
Chrome.
Okay.
But it's my computer. My computer's like 9,000 years old. Okay. Almost there. Okay, I've click start now. Finally. Okay. True and yeah, are you guys into?
Yep. Mm-hmm.
Number 3. Who wants to read number 3?
Find the margin of error for a 90% confidence interval when the standard deviation is 50 and 25.
Okay. Come on. So the 90%, we've...
It's 1.645.
Just a question, how did you get that?
You just put the
1.645.
0.90, right?
You go to the normal probability applet,
Oh, okay.
read the middle, and you make sure the tails aren't shaded, and then in the area you put 0.9.
Alright, cool.
This one, because when
But do you...
we had the 541, but I don't know.
Don't we still do like the 1.65 times 50? You have to do that as well?
Yeah. But you know how in part 2, how we had for example, we had 541 plus or minus 1.96 times 32 over the square root of 50.
Uh-huh.
We don't have a number like 541, so do we just do it without it?
Yeah, because
Yeah, oh, go ahead.
sorry. Yeah, because I read somewhere in the answer sheet, in one of the answer sheets where it talks about that. Because he gave us 2 answer sheets this time. I'm trying to remember. Yeah, it on the one that says individual preparation worked solutions, on number 12, it says, remember the margin of error is just the second part of the equation, or the plus or times, whatever.
Alrighty. So that would be 16.45.
That's what I got.
Wait, for number 3?
Yep.
Mm-hmm.
You said
Yeah.
0.45?
16.45.
Yeah.
Should we add a 0 just because it says 3 decimal places, or should we just leave that?
I usually just
think
leave it.
16.45 is.
We can email them if it's wrong.
Okay. Which? Who wants to read number 4?
I can do it.
Okay.
Which of the following statements is true? I don't even know what to call that sign. Anyhow, it's a point estimator of x. O is an interval estimator of O squared. X is a point estimator of that. 0 or O squared is an interval estimator of x.
Oh, wow.
Hold on, I'm trying to get in the.
I want to say bar is a point estimator of the mean, but I'm not quite sure if that's right.
In the reading, it says the actual formula for 95% confident in. Oh, wait, never mind. Sorry. Wrong part. I'm looking at one thing. Dang it. Wow.
I think X bar is a point estimator for the mean. That's what I'm seeing under 3.1, but I'm not quite sure. Where'd it go?
It's got to be the slowest computer in my whole life. Sorry, you guys, I can't. My computer's being stupid. So you said which section?
3.1. It's on the last paragraph. The last paragraph.
confidence interval. Do y'all agree or no?
I'm looking.
Ooh, those are flipped. It has to be one of those because they wouldn't have flipped it.
Ow.
Um,
I can't find anything else, so.
then the sampling distribution of X will have a mean of
See, when X bar is normally distributed, is the O thing standard deviation?
Yeah.
Yeah, standard deviation is assumed to be known. It's in 4.4.
4.4.
Yeah. But I don't, that's not even one of the choices. Should we go with X bar as an estimator of
The mean.
yeah.
Yeah. Quiet. Okay. Who'll read 5?
I'll read it. Gina wants to construct a 95% confidence interval for GMAT scores. She knows that the standard deviation O equals 113. She collects a simple random sample of size n equals 64 and computes x bar equals 526. Use this information for questions 5 through 8. Okay, so what is the lower limit of this confidence interval?
526 minus the 95 confidence, which is
1.96, the z-score.
1.96 times 113.
And then the lower interval, or the lower limit is the subtraction, right?
Yeah.
You get 498.315.
That's what I got.
Oh, I did the higher one. I mean, the upper limit.
So 498.315, right?
Mm-hmm.
Yeah, that's what I got. You got the upper limit. We need that for the next one.
Okay.
What did you
I
get?
got 183.685. Might want to check it because I don't know. I'm not good at math, so.
553.685. So
That's what I got.
Okay, no, I did not get that. I don't know what I'm doing wrong here. Oh, I found my problem. Okay, sorry. Wrote down one of the wrong numbers. One number is wrong. Boom.
What did you get?
553.685.
Yeah, that's what I got too. Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
It would increase, wouldn't it? Yeah, it would increase because in the part 2, the margin of error decreases as the sample size increases. So the confidence interval would increase if the sample size increases because it's going to be the opposite. Right?
I think so. Is the confidence interval, is that the area of, in the normal probability applet, is that the middle area? If it is, then that is true. But I can't remember. I think, because I did it somewhere in the homework.
Yeah.
Or the preparation.
I feel like
because the bigger sample that you have, the more you know it's going to be true.
Mm-hmm.
Well, we could always test it and just use a bigger number and see. Like, what are the numbers? If the sample size is larger? There it is. That would be n, right?
Yes.
Okay. Or mine actually decreased when I increased the sample size. I used, instead of 64, I used 70. Six, 26.47. Yeah, mine decreased.
Yeah, the larger the sample, the smaller the confidence. For the
7 is decrease, and that'd make it increase.
The larger the sample, the smaller the confidence interval is what I just read.
Yeah, I just read that too. Okay. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
Wouldn't that one increase?
Yeah, that one increased.
Increases.
Okay. Someone want to read number 9?
Yeah, sure. Bright bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours, and they want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
That's the sample size form.
Yeah.
Squared. I got 246.
One second.
I'm not there yet.
You got what?
246 or 245.86, but then we had to round up.
How did you get that?
I did the z-score times the standard deviation divided by the margin of error, and then squared all of that.
Oh, dumb. That's probably why.
Oh, yeah.
I messed up there.
What did you divide it by?
The margin of error, 50.
You said 245 or 246?
Yeah.
Okay, cool.
Yeah, that's what I got.
Yep, same here.
Diamond, did you get that?
I got 243.36.
246. If you take 1.96 and times it by 400, then divide it by 50, it's 15.68. And when you square that number, it's 245.8624, which rounds up to 246.
Okay. I don't know why my phone did that. It rounded before it needed to round, so that's why I was off. Perfect. Got it. Okay. Number 10. Who wants to read number 10?
I'll read it. The mean salary of actuaries is U equals 10 or 100,000. Wow. And the standard deviation is O equals 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance A or alpha equals 0.05, and the null hypothesis is the mean equals 100,000. The alternative hypothesis is the mean does not equal 100,000. You collect a sample, or a simple random sample of n equals 36 women's salaries and find that x bar is equal to 111,000. Use this information for questions 10 through 12. What is the lower limit of this 95% interval, or confidence interval?
Are we supposed to be using 111,000?
Yeah.
Mm-hmm.
Okay.
It's a really big number.
Did you get 99,001.53 or 99,001?
Oh, I did the upper limit. Dang it.
What'd you get, Diamond?
99,001, or I guess 002.
Are we supposed to round up on? Yep. Yeah, I got that same.
You got that as well?
99,002, yeah. So 99002.
Okay, that's what I got. For the upper limit, I got 1,022 or 122,998.
Me too.
Yeah, but it would be 99 if we're gonna round up.
Well, then I got. Oh yeah, because just kidding. Sorry.
Wait, it would be. Wait.
Because I got.
Because mine is 0.46, so wouldn't it stay?
Yeah, that's what I got.
No, you still have to go up because. Okay, in the homework, when it said to round up on question 13, it was 157.35, so it said to round to the nearest whole number, and you had to round up to 158. That's the only reason.
Oh, you're right. You're right.
So
Yeah, because then you wouldn't have everyone.
Yeah.
You wouldn't count everyone if you round. That's right.
So the last 3 digits should be 999?
Yeah.
Mm-hmm.
Oh,
122,999.
yeah.
There are 3 requirements that need to be checked. What are they? So,
A simple random sample was drawn from the population. X bar is normally distributed, and
I think they're all right.
So,
yeah,
they are.
Yeah.
all of the above.
all right, cool.
Then press submit. Got an A.
Woo!
Cool.
Yeah! We're so smart, you guys.
Yes.
Does anyone have any questions furthermore?
No. Oh wait, on Thursday, would it be possible to meet earlier at all?
On Thursday?
Yeah.
Yeah.
Well, I get off work at 5, and then I have a meeting, or I get off work at 4, and then I have a meeting that starts at 5.
Are you going to the health psychology thing?
No, because I have a work and a service meeting that I have to go to. Is it on Thursday?
Yeah, it's on Thursday. I can't go either.
What time?
Yeah. It's at 5.
Yep, definitely can't go.
Yeah, I can meet anytime after 12:30.
So
I can meet anytime after 3. So.
do we want to try to do it in between 4 and 5, and I'll just log on right after work? Does that work?
Wait, can you not do it at like 3:15?
I don't get off till 4.
Oh, I get it. Okay.
And then I have it starts at 5 and goes till 7.
we can shoot for 4:15.
That'll work. I'm just going to stay on campus, so I'll just walk to an empty classroom.
Okay.
Sounds good.
Alright.
Sweet. 4:15.
Thank you.
Okay. Bye.
Okay, bye.
Bye.